Lists are perhaps the most important sequence type there is in programming. And we'll see in Python, these lists are very flexible and will allow us to solve many problems where we have an ordered set of data that we want to work with. So let's get into it. Lists are a sequence of values because they are a sequence type. They're an example of a sequence abstract data type where we can change the items at runtime. So when our program is actually in motion and we're working with it, after we've constructed a list, we can add new items to the list, we can change existing items in the list, we can remove items from the list. So it's a dynamic data structure that is mutable, meaning we can change it while our program is running without having to create a whole new list. Right? And so this will bring great power and some great responsibility that we'll look at as we get into some of the memory implications of it. But we think about a list as an ordered sequence of values of the same type. And this is consistent with how you imagine lists, or often they're called arrays in other languages as well. So here we can imagine a list of integer values. And the way that we'll specify a type list with that holds any number of integer values is list with a single int in it. So that type is going to say, the type of every item in the list is going to be an int, right? So this is a little bit different from a tuple type. And we could have lists of strings, we could have lists of colors, we could have lists of lists, we'll see later on. We can have lists of any type we want, and we just specify what type of list the list is made of. The items in the list are going to be inside of those square brackets. We call each item in our list, or each element in our list, an item or an element. So these are synonymous with one another, and this is kind of a recursive definition. Each item in a list is called an item. And you'll see in the Python syntax that items are what Python likes to call these. In other languages, you'll see element, and if you read things in books, you'll probably see the word element as well. So again, this is a composite container data type. It's a sequence of many items. And an element is represented or accessed by its index, right? So we've seen this with the subscription notation, and we'll look at it in more depth in just a moment. All items in a list for our purposes in this course, and generally it's a best practice, are going to be of the same type. So we'll have lists of ints, lists of floats, so on. If you see the word array in any of our course materials or out in the world, in many other languages, the same concept would be called an array or some variation on it. So there's some terminology that gets used in different ways in different contexts. In Python, this data structure is called a list. There's a footnote down here that I'm not going to spend any time discussing in the video because we're not going to look at lists that hold many different types of data. That adds a lot of complexity to the algorithms that you would write in order to work with lists that have many data types embedded in them. But know that it is possible in Python if you really set your mind to it. It's much harder to write good, probably correct programs if you use multiple different unrelated types at any point in your list. So we're sticking with lists that hold items of a single type. But we can change that type, and when we can decide when we're working and when we set up this list value, we'll be able to decide for any kind of list we're working with what type of data we want its items to be. So as I mentioned, that when we have a list that is assigned or bound to a variable name, in this case you can imagine, let's call our list array underscore name, we can use this subscription notation to access specific elements, right? So if we had a list named A index 1 would be the list's name A, and the index 1, and that would refer to this particular item in our list A here, right? And we always start from 0 with our sequences. This is true with tuples, this is true with lists, this was true with strings, and it'll be true with ranges as well. One of the defining characteristics of what a sequence is in Python is a set of ordered values where the first value has an index 0 and is accessed in this way. This has the trade-off that you all are familiar with at this point, where if you want to find the last index in a sequence, you have to take 1 minus the length or the number of items in a sequence in order to compute it, right? And so in order to know that the highest index in this particular list would be 7, we would count that, okay, this is 1, 2, 3, 4, 5, 6, 7, 8 items that are in this list, and we would subtract 1 from that to get the highest index. And again, that off by 1 is due to the fundamental property that we will begin indexing with 0 here. This is true in just about every programming language you'll want to use. So how do we actually declare and work with lists? Well, just like with tuples, we need to import the list type in order to specify it in our programs in the way that we want to. We'll be able to declare variables of lists of integers, lists of strings, so on and so forth, where we say our variable identifier name, colon, and then the list type, and then we'll be able to assign a list after that. We'll see that there are 2 ways of constructing a list, and we're going to focus on the list literal syntax in the first example here. So let's go ahead and I actually think for our purposes, we're going to add another import here. So from typing import tuple and then list. And what we're going to do is let's set up a main function that just gives some list examples. And we can do this. I'm going to leave that type definition for color at the top here. And I'll set up a main function that returns none. And for now, I'm just going to say, we'll come back and fill that in later and set up my idiom here, which is if name is equal to main. When we run this program, then run the main function, or call the main function. Okay. So let's set up some examples of list. We'll call this sequences. Okay. So let's say we have a list, and it's going to be a list of integer values. So a list of int. The way that we could initialize it with a few values is maybe we give it some course numbers like 110 and 210 and 211 and 301 and 311. These are some of the introductory sequence course numbers in computer science. And maybe we print out the contents of this list after we initialize it, right? So let me see, I'm gonna have to make this a little bit smaller again to fit the entirety of the code on my screen. Let me just break down the sequence, the syntax that you're seeing here. So again, just like we've defined variables in the past, we're setting up a local variable in this main function named alist. Its type is a list of integers. Right? So when we're working with lists, we're not going to use aliases like we do with tuples, because this is actually pretty descriptive of what we're working with, and we only have to specify the type once, no matter how many integers a list is going to hold, or no matter how many strings a list is going to hold. That type that we specify in the square brackets of our list is saying every item in this list will be of this type. We'll try making a list of strings in just a moment to prove to ourselves that we can do that as well. For list literal syntax, we have these square brackets that when you use them as a value in this way, so notice we're using this on the right-hand side of the assignment operator, and we're setting up some more literals in here, and all of those literals are of the type that matches. So 110 is an integer that matches up with the type of list that we're working with. 210 is also an integer, so on and so forth. If we tried to initialize this list with values that were not integers, we would have problems. Right? So let's try running this program, and I need to quit out of my previous example, save my code, and run Python -m, and we're going to just run this as a module, which will cause this main function to evaluate. That -m means run as module. Lessons.ls21 sequences. And we see that this list is printed out, and notice we've got multiple values in it. Well, we can also print out, and maybe I'll make a note here for reference purposes, access items using subscription notation. And if we wanted to, we could loop through each of these. So we could say I is an int that initially is 0, while I is less than the length of a list, I plus equal 1. I like to, when I'm writing my while loops, be sure to go ahead and change my counting variable to be sure that I'm making progress towards my ending condition. So we're going to stop looping once I is equal to the length of a list. And remember, that's what we want, because the maximum index of this list will be 1 less than its length, right? Just like with strings, where we could ask a string, what is your length? We can use the length, the len function on any sequence, and it will tell us how many items it has in it. So we can print out a list at index I. And notice we're going to move one by one through each index in this list, and we would expect to see on individual lines printed out 110, 210, 211, 301. And when I ran that program, if I could get my screen to show up correctly here, sure enough, we printed the list in its entirety first, and then we went through item by item and printed each after that. We'll learn in the next lesson how to use a special kind of syntax for making this kind of loop much easier in the future. But for now, I want to bring this back to a fundamental concept of using an index to move through programmatically each subscription index in a sequence, because this is a pattern that you'll see throughout many other languages and in many other contexts that you need to be comfortable with in order to understand what's going on under the hood. All right. So that's how we initialize a list with list literal syntax. This is how we access individual items in a list with our subscription notation. And notice that this index is an integer expression. So we can compute things here. We could have more complex arithmetic happening here. And this is where some of the magic that happens when we're processing lists and creating algorithms for lists will occur. All right. So just as we saw, if we wanted to actually initialize an empty list that has no items in it to begin with, we could do so with just an empty set of square brackets. We talked through the list literal syntax. This slide is mostly here for reference purposes. And we could, and actually it's probably worth adding an example of this to our code. Let's go ahead and set up one more list of, say, names. So names is a list of strings. That will be the strings, Chris, Khaki, insert your own name, Esri, right? So a couple short names, and we can print that names list out as well. And so this is a variable that references these three values. And if I were to run this code, we see that sure enough, we can make a list of strings too. And that's pretty cool. If we were thinking about how does this program actually evaluate when we get into our main function. So I'm not going to do a complete diagram here, but just to give you a little sense, let me see if I can make this a little bit smaller. When we get into our main function, our return address would be somewhere down here. I'm going to call it like 30, line 30. I'm guessing at that. And we set up a list. So what is a list? We're going to spend more time looking at this in depth on Thursday. But a list is going to refer to a list, and that list is going to hold many items. And this will be on the heap. Right? So this is our stack. And let me just put a frame around this. So that list is going to have at index 0 the value 110. And this will be a table, is one way of thinking about what a list is. At index 1, 210. At index 2, 211, at index 3, 301, at index 4, 311, right? And that would be what a list is bound to in the main frame. When we initialized names, what we would have done is we would have said names is bound to another list that's separate, right? So this would be a list where index 0 is Chris, the string, and index 1 is Khaki, the string, and index 2 is Esri, the string. Right? And so hopefully you're getting a sense, and this is a quickly drawn diagram. We'll spend more time on the diagrams as we get into practicing working with these sequences. But we're storing these values on the heap, and a sequence or a list is really just an indexed table of values that we can work with. So what else can we do with lists now that we've seen how to construct them and how to initialize them with list literal syntax? We'll see there are some other ways that we can initialize lists that are very cool and very powerful. We're going to save those for later though. Once we have a list, we can append new items to it. So this is one of the superpowers of a list relative to a tuple. A tuple, once you have a tuple, it's fixed in length, right? And you know exactly how many elements it has, and you can't change that. Well, with a list, you can append more items to it. You can keep adding on to the end of it. And so if we wanted to, we can append a value, and let's go ahead and give an example of this. So let's say we wanted to append a name, so names.append, and we're calling a method, just like we've seen, you know, turtle methods, string methods. Here we're saying, hey, names, I want to give you an instruction specific to you. I'm calling one of your methods, which is a function that's built into the idea of a list. And specifically, we're saying names. I want you to append the name Mark, right? And if we were to print the names again, at this point, we would see that we have, in fact, notice the first time names printed out, the first time names printed out, we had Chris, Kaki, Esri, and the second time we have Chris, Kaki, Esri, Mark. So with lists, we can append new values to it. Now this is really cool because that means we could ask the user a number of questions and keep track of every response. That means we could read in a big data set. And as we're reading in that data set, we can store each of the data points into a list that we can then go compute on later. And we'll be looking at that very soon. And so we get a lot of flexibility. We can build up lists dynamically as our program runs. Notice we started a list with a few items and we went and added more to it. And this is why it can be handy to start out with an empty list, right? We can remove elements from a list. This is a funny named method, but I'll talk about why it's named in the way that it is in just a moment. So we can pop items from our list. And there are two ways that we can use pop. We can either call the pop method without an argument, and in that case, it will pop the last item in our list, so the very last item. And when it pops, it returns that item to us so that we can use it if we want and removes it from our list. And then otherwise, we can pop a specific index, and that would be like saying, hey, just pluck out one index, remove it from my list, shift everything after that element back down, and then we can, we'll have a new list and it will give us back that element as a return type. To demonstrate this, I actually want to do it in a REPL because I think this is a little bit easier to demonstrate. So let's try starting up a Python REPL, and I'll make this a little bit bigger. And from typing import list, so for good measure, we're gonna strongly type our example here so that we're writing the same kind of syntax we would in our program. You should know that the type checking only occurs in your code editor and when you submit and when we run specific tools that check our types. When we're working in the REPL, you can actually make type errors and it won't really complain at you. But here, we're just gonna, for good measure, say that we've got, say, a list of names. That is a list of type string. And let's initialize again. Let's do it empty for now. So names is the empty list. And we see that names has nothing in it. If we ask what is in names, the REPL prints back out to us that it's empty. We can say names.append Chris, names.append Ada, and we can check, well, what's in names, Chris and Ada. We can add the name of my other dog, names.append Nelly, and we have 3 names in our list, right? So which of these is not like the other? Chris. So if I wanted to pop off index 0, I'm going to do this using a variable, right? So I'm going to say popped name is a string variable that's the result of calling the names function, the pop method on the names list. So this is a list of strings, and we're going to pop off index 0. So if we look at, well, what is in names now? Notice names is Nelly and Ada, and if we looked at what is names at index 0, that's Ada. So we've shifted every item back. And if I looked at what was in the popped name, we see that the result, the return value of calling this pop method on the list and giving a specific index is whatever item got popped off is now being assigned to the popped, is what this expression evaluates to. And we took that expression evaluation and assigned it to this variable. So popped name is Chris. Just for good measure, we could also demonstrate the other form of popping, which is you don't give any index at all. And when you call pop in this way, it will pop the highest index off. And so now we would expect our list to just have Ada in it. And if we look at our names, sure enough, it does. And if we looked at, well, what was the name that we just popped off? That would have been Nelly, all right? So we can append items, we can pop items, and we can modify items as our program's running. In fact, let me just give you that. Did I close it? No. So I've still got my terminal open. And if we look at our list, we see that our names list is just one name. So let's add Nelly back. So names.append Nelly. So now names at index 0 is Ada. Names at index 1 is Nelly. And one of the things that we can do with a list that we can't do with a tuple, we can't do with a string, and we'll see that we can't do them with a range either. So this is special to lists, is we can modify items at specific indices. That means we can say names at index 0 is actually going to be Chris, right? And so what we're saying here is take the value, the string Chris, and bind it to the names item at index 0. So now if we looked at, well, what is names? Names index 0 is Chris. Similarly, names index 1, if we reassigned that to be Khaki and checked our names, we could overwrite or rebind index 1, right? You've got to be careful though, because if we try and bind to an index that doesn't exist, you'll see an error. It says that your assignment is out of range, where we tried to assign to an index that didn't exist. So if you want to add on to the end of a list, you need to append to it. Some of the fundamental list operators that you'll be comfortable with over the course of the semester are: how do we declare a list type? How do we construct it? How do we check its length, the number of elements? We've seen how you access a specific element, and we've looked at just now how you assign to an element. And then when you want to add on an element to the end of a list, you can do so with append. If you want to remove an element, you can pop it. There are other operations that you can do on lists too, but these are some of the most fundamental ones. And we can start to write our own algorithms to help us introduce new functionalities to when we're working with lists, if we'd like. And we'll look at some more functionalities built into Python in the future as well. This is an introduction to the sequence type that is a list. And a list is probably the most special and most useful of our sequence types because it allows us to change its values as the program's running. And we'll see that this is really a workhorse for many different computational problems when we're trying to algorithmically process lots of data.